converge?
The absolute value of R is less than 1.
When does it diverge?
Absolute value of R is greater than or equal to 1.
When does a telescoping series converge?
Always.
When was the only time we'll use a telescoping series?
When it asks for the sum of the series.
When it asks for the sum. And what will we more than likely have to do to a series to make it look like a telescoping?
Partial fractions.
Partial fractions. When does a P series converge?
When P is greater than 1.
When does a P series diverge?
When P is less than or equal to 1.
P is less than or equal to 1. What? Alright, so those are my types. And we're going to learn our last type of series today, even though we kind of already talked about it. Whoa. And today we're going to learn alternating series. You don't have to write that yet because we'll get to that. Alright, so the test. What's the first test I should always use, but it'll probably fail 90% of the time?
Nth term.
Nth term test. Which tells me the limit as n goes to infinity of a sub n does not equal 0, then the series diverges. When does an nth term test tell me a series converges?
Never.
Never. Alright? What's the next test that I should use?
Ratio.
Ratio. When should I always use ratio test?
When there's factorial.
Radius of convergence. And if I'm finding a radius of convergence, that's going to be what kind of series?
Power.
Power. I think I heard it. Power series. What makes something a power series? X. Alright? So the ratio, we're looking at limit n plus 1 over n equals L. When is it going to converge?
When L is less than 1.
When is it going to diverge?
L is greater than
What
1.
happens when L equals to 1?
You don't know
Tells you
anything.
nothing. And more than likely, if you use a ratio test and you get the limit equals to 1, more than likely it was some form of a P-series. And whenever we have P-series or something that looks like a P-series, we should use what test?
Limit comparison
Limit
test.
comparison test. And that's where we're given one and we pick one. And then if that L is finite and positive, aka it's not 0 or infinity, then the series are going to act the same. And then if all else fails and every other test that we have done fails, I'm going to use the integral test. What are the big 3 things we got to remember about integral tests?
Positive, continuous, and decreasing.
And then there, the integral from 1 to infinity is going to act like the sum. So if the integral converges to a number, the sum is going to converge to a number. If the integral diverges, meaning goes to infinity, the sum is going to go to infinity. Okay?